right, so let's talk about the homework that is due today, okay? And we can talk about this again on Monday, but I feel like if I can go over this together, you might be able to notice, hey, do I have answers that are correct or incorrect? Okay, and so let's look at these here. So the deal is on number one, you would add up the two parts, okay? The two parts that form this whole segment is going to be x plus 4.3 gives you the sum of those two parts. So x plus 4.3 gives you 7.9. So if you solve that equation, you're going to get the value for that segment PQ to be 3.6. So technically I wrote PX or X, you could write PQ, okay? So PQ, the measurement of PQ of that segment is going to equal 3.6. So you notice I didn't put a segment over it because I want the measure of PQ. Okay, the next one, notice it says, can you tell me DF? Well, if you add those two parts together, you're going to get the overall length to be 18.4 feet. And so DF is equal to 18.4. So I could have written DF, okay, and then notice I don't have marks, so I mean the length, okay, the length of DF is going to be 18.4. Okay, cute. So then the next one, if I add up the two parts that make the total segment are going to be 5.9 plus X, and that gives you 12.3. So add those up, you get 12.3. Solve for the value of X, and X is going to be 6.4. And we could be real fancy and write, oh, segment BC length is equal to 6.4. Cute. On number 4, you can kind of see the answer, can't you? You want to find out QS, which is the overall length. And because those segments have hatch marks, that means they're congruent. They have the same length, okay? The same shape and size. And so because this part right here, QR, is equal length to RS, well, then that means that they're both 4.2. So if you want to know the overall length, you could plus those two up and get 8.4 feet. Okay, so the length of QS, the measure of QS, is going to be 8.4. On number 5, well, you can see, like, we know the whole, and we know that each part is equal to each other because of the hatch marks that you see. Like, look at the single one there and the single one. That means those two match in length. And so therefore, if you take the whole and divide it by 2, you're going to get the length of each of those segments. So they want FG. Well, FG is going to be 7.1, and so would GH because they match in length. Okay, the one below it. Yeah, you could plus up those two measurements on 6 and set them equal to the total, but I don't know that. So the thing is, I teach you things and I say, okay, this is true, okay? And if it applies, then use it. Okay, but sometimes in geometry, you got to say, that's not going to help me on this problem. What else do I notice about this figure? Or what else do I know about segments? And the truth is, because those two segments match in length, we can set each of them equal to each other and solve the resulting equation. So because CD is equal in length to DE, we can set each segment equal to each other and say, okay, solve it by distributing, subtracting to get the X to the same side, move the numbers to the other side, and you get the value of X to be 8. Now that's all they ask you for. I just thought it'd be cute to find the length of each segment by plugging in the value of X into that segment expression. So I went up and took 8 up here, and I said, ooh, 3 times 8 is 24, and 24 minus 6 is going to be 18. Okay, so therefore, if you plug in X is 8 into the other one, you get 18 for the other length. And notice, hey, look, they do match in length, don't they, when you plug in X? So sometimes they make you check things. Sometimes it's just nice to check it. On number 7, you could plus the two segments up and get them equal to the total, but I don't know the total. Okay, so it's true, but not helpful. Just like, oh my heavens, I see green grass behind me, and I see like a chair. Okay, cute. Does that help you do your math problems? And the answer is not really. Okay, but is it true? Yes, but true and helpful are two, not always the same thing. And so we are going to say on this one, because we find no value of saying add them up and they make the total, which is true. To help us write a true equation, we're going to set each segment equal to each other because they're equal and solve to find X. And then if you want to, apply it to find an expression, you can. In this case, it just said stop and find X. Okay. Below on number 8 and 9, okay, this is where you can add up the two smaller parts and set it equal to the overall total. So the sum of the parts equals the total. Okay, so if you add up all your parts, all your intestines, then you get to U. Okay, what makes you? So if you want to add up this entire segment, you plus each part together and you set it equal to the total length. And so x plus 17 plus 3x plus 26, combine like terms on the left and solve, you get x is negative 7. Well, you learned in Algebra 1 that the value of x can be negative, but you also learned in real life that your answer to a length should not be negative, should it? But when we found x, that is not a length of any part of this problem. It's just the value of x. So if you choose to plug in x is negative 7 into either expression, I just found DE just because I thought it'd be cute. Plug in negative 7, you do 3 times x and then plus 26. I did 3 times negative 7. I got negative 21 plus 26. And I got the length of DE to be 5. So if you tried it in both of those, you could figure out, hey, guess what? Not only is x negative 7, but it also works. And together, those two segments form 15 when you find this. I bet you CD will be 10 if DE is 5. So if you plug in negative 7 to this first expression, negative 7 plus 17 does give us 10. So just heads up. The next one is easy. You add up the two parts and set it equal to the whole, okay, and then solve to find x, and you get x is 6. If you want to find the length, you can, but it doesn't make you. Okay, below here, we can set up the sum of the two parts equals the total. Again, up here, we didn't know the total, so we had to work with what we had, and that's part of it is like, what do I have? How can I use it to get to what I want to know? So this says find x and then find CD. So here's where we do take it up a notch. So you add up the two parts, so that'd be 14 and then plus x minus 1 and set it equal to the total, which is 4x minus 8. Combine like terms and solve, and you get x is 7. Okay, move the x's to the same side, the numbers to the other, and solve for x. X is 7. So that's step 1. Step 2 said find CD. Well, CD is right here, okay? CD is right here, and CD is x minus 1. So to do this, you take x, which is 7, and subtract 1, and that's what it's going to be. You get 6. So this length of CD is going to be 6 units. Label your answers if possible. Okay, the last one on this page, again, add up the two parts, set it equal to the whole, solve for x, the x is negative 10. Oh dear, it's done. No, when you find x is negative 10, make sure that it doesn't make your segment length negative. So when I plug in x is negative 10 to find DC, well, DC is 28 plus 2x. 28 plus 2 times x, x is negative 10. So 2 times negative 10 is negative 20. So 28 minus 20 is 8. So DC is 8 units. The world does not end. The segment length is positive, and that's completely fine. So x is allowed to be negative. However, the length of segments and measures of shapes are really not supposed to be. And you know that intuitively. Okay, let's go to the back. Now, here's where you've got to read. It says you've got A, B, and C are collinear. Point B is between A and C. So put point B between A and C. And then it says AB is going to be 3x plus 14. BC is 3x plus 17. And the overall length is 21. So you add up the two parts and set it equal to the total over here. Solve for x. You get x is 0. Again, x can be 0. X can be negative. We learned that last year in Algebra 1. However, when you plug in x is 0 to find BC, like they ask you, BC is going to be 3x plus 7, so 3 times x plus 7, so 3 times 0 is 0 plus 7 gives us 7 units. It's going to be BC. So follow the directions. You can see the answer to 13. They tell you AB, they tell you BC, they tell you AC. So add up the two parts, 15 plus 13x, set it equal to the total, which is 26x plus 2. Solve for x, you get 1. Plug that expression back into, they want you to find AC, okay? And your answer is going to be 28. So kind of cute. All right, let's go to the shape. Name the plane. You got a couple ways to name it. Plane R, okay, plane, and then pick 3 points that are not in a row. If you don't do in a row, or if you do in a row, you may be talking about a different plane than somebody else. So pick 3 points on the plane that are not in a row and write the word plane. Name 3 different lines. I have them in colors. Okay, there's different ways to name my green one. Pick 2 points on the green one and put a line with arrows above it, or you write the word line. Same with the yellow one. Pick 2 points on the line and put a line above it, or write the word line. Put arrows on it too. Same with the pink one. JK is a good choice, but you can use any 2 points on the pink line and put a line above it or write the word line. 3 collinear points. There are 3 options for what you could do. Okay, if you chose the green line, you could do A, P, and B, the yellow, or whatever. You'd say points, blah. Okay. Non-collinear points. Pick 2 that are in a row and 1 that turns a corner. So you've got a lot of options. So APD, I go AP, oh, turn a corner to make D. So 3 non-collinear, they're not in a row. 4 coplanar, okay? Give me 4 points that are on the plane, okay? It just shouldn't be J or K because those are not on the plane. Notice they're held up by a stick, okay? And then Name a point that's not on plane R. Well, point J and point K are, on a tower above or below the plane. Okay, and so J and K are on that tower. They can't touch it. Okay, so they're above it. Name two lines that intersect at CD. Those are shown. Okay, JK, the pink line and the green line intersect at segment CD. Where do they intersect? At point D. And then drawing these, okay. It says draw two lines, name the points. Y is collinear with R, so make sure Y is on line with R. And Z is not on the same line as both N and S. We'll just put Z someplace where it's collinear maybe with one of them but not the other, okay. Just can't be collinear with both of them. Did you name the points? Did you put the point of intersection at G? Did you draw a parallelogram to make a plane? Okay. On the bottom, did you draw two lines? Did you name them? Did you put some points on the plane? And then did you put point P on a tower above or below? So make a stick that goes into that paper, into that plane, that holds the point P above or below the plane so it doesn't intersect it. Good job.